Hi everyone, so this is question 8 that we are going to solve right now. So let's have a look at the question. Okay, so you are being told that there's a 3 kg body. Okay, translate into mathematical form, it will be m equals to 3 kg. And this body is oscillating in simple harmonic motion, SHM. If its kinetic energy K changes with displacement X as shown in the figure below. So the thing that is changing is K is changing with displacement X. So you have K against X graph here. Okay, so this is a graph of K against X. So they ask you to find amplitude, period, and maximum acceleration. As usual, if you are solving a question, it's important that we are able to extract all the information from the graph itself. So this is our first time encountering kinetic energy against displacement graph. So I think it will be appropriate for me to explain what this graph means first. So let's go down here. Okay, so this is a kinetic energy against displacement graph. Usually, how would I imagine this thing is, I'll imagine it using a spring mass system. Okay, if I have a spring mass system, then say this is my spring. Then my mass will be somewhere here in the equilibrium position. So the equilibrium position is here. This will be my mass. Okay, so my mass will be oscillating within negative 0.2 meter and 0.2 meter. So it will be going this way, it can be going back this way, then it come back to this position. Well, it's oscillating around this negative 0.2 meter and 0.2 meter. So let me draw two image of the block in different position. One is at this amplitude and another one over here. Okay, so our mass here will be oscillating around these few regions. So we can say that this will be our amplitude, and our amplitude is 0.2 meter. Well, amplitude works both sides. So you have 0.2 meter as well. Okay, after knowing that, let's try to analyze the energy of this mass. Okay, what we know for sure is when the body is at this position, what will happen is it will undergo a U-turn, and when the body is in this position, it will undergo a U-turn this way. Okay, so when an object is going to do a U-turn, we can say that the body will be at rest at this position. Okay, body at rest, and the body will also be at rest. If we say a body is at rest, it means by the kinetic energy will be equal to 0. Kinetic energy will be equal to 0. Just like what we see here. The kinetic energy is equal to 0. Okay, so how about in the center when it's at the equilibrium position? If it's at the equilibrium position, it will be traveling at maximum velocity. Okay, if you can't imagine what is maximum velocity, you already have zero velocity here. You have zero velocity here, and in the middle of it, you should be probably moving in the maximum velocity. maximum velocity here. Okay, so with that I can write, since the velocity is maximum, I can say my kinetic energy is at maximum as well. Okay, that's why you can see here at the equilibrium position, the kinetic energy is maximum. The next thing that we can note is when the body is at the 2 amplitude, for the left hand side, we can see that it's at maximum compression, spring compression. Okay, the spring is compressed at its maximum here, then only that it will be spring back to the equilibrium position. So at this place you can say the U is equals to U max. Okay, we have no UX graph here, later we'll try to draw it. Again, for the most left hand side, most right hand side, we can say it's at max spring extension. Okay, after if it's at its spring, it is at its max spring extension, therefore U is also equals to U max. If the potential energy is at its maximum at both of the amplitude, we can reasonably deduce that at the center U should be 0. Why U is 0 is because spring is not extended or compressed. Okay, our spring is at its equilibrium state. It's not extended and it's not compressed. Therefore, if you try to draw a diagram for U, it will probably look something like this. Let me dot this out first. Dot this as well. So it will probably be maximum dropping towards 0, coming back up. Looks terrible. Going down, coming up. Okay, so that's how the the elastic potential energy should look like. Okay, since we know how the K and the U changes with displacement, we also know that K plus U, we also know that K plus U is equal to total energy. Okay, K plus U is equals to total energy. And since K plus U is equals to total energy, we can try to prove whether it's true or not. K, we know that is half mv square. U is half kx square. Then this probably in SPM. So we know that V square is basically just omega square root a square minus x square, a formula that you use quite often, square plus half. Okay, K, you know, is related to omega using this formula. So if you want K, it become m omega square. So half m omega square is x square, V equals to E. Now let's rearrange the whole thing. Become half m omega square a square minus x square. And this one will be half m omega x square equals to E. Okay, so this is the term that you probably use quite often. This one you probably see in your formula sheet. This is representing kinetic energy, and this one is representing the elastic potential energy for spring mass system. Okay, so if you insist of summing them up, let's open up this bracket. So if we sum them up, it will be half m omega square a t square minus half m omega square x square plus half m omega square x square equals to E. So we can see quite clearly here that this negative and this positive will cancel each other out. Therefore, we can see that the total energy is equals to half m omega square A square. Half is a constant, it won't change. The mass of the object, you won't change it. Omega doesn't change. Amplitude doesn't change. All constant. That's why your total energy is a constant. That's why if you try to draw the line for total energy, it will probably look something like this. Okay, let me label it. This one is E, representing total energy. This will be U, representing the elastic potential energy, whereas the black color line will represent kinetic energy. So let me just remove this because it might be confusing. Okay, so this is how the three energies are related to each other. Okay, the sum of the K and the U means by at every moment, if you sum up this and this, you get E. If you sum up this and this, you will end up with E. If you sum up this and this, if you sum them up, you get E. If you sum up these 2 points here, you get E. Okay, if you sum up the K and the U, you always come up with a constant, which is the total energy. And the total energy is constant at all different displacement of the SHM. It's always constant. Okay, so that's the idea behind this energy graph. Okay, I believe we have detoured quite for a long time to talk about this graph. Let's get back to the question. Okay, so we are given a graph here, and it's a kinetic energy against displacement graph. So before we start to solve a question, let's extract everything that we know about this graph maybe. So what we can know for now is that the most straightforward thing to get is this distance here will just be our amplitude. So our amplitude will be 0.2 meter. Okay, you can think of your SHM going between negative 0.2 and 0.2, going back and forth. Okay, so that's one thing to extract. Another thing will be the maximum kinetic energy will be 45 joule. Okay, there's a lot of information. Let's list it down. Mass is 3.0 kg. The amplitude is equals to 0.2 meter, and the kinetic energy will be equals to 45 joule. Okay, knowing these three things, okay, we can probably start to solve the question. Oh, the question A, straightforward, asks for the amplitude, and we already listed it down, so you can just copy that to be 0.2 meter. B is asking for period. Do you have anything regarding period here? I can't see anything relate to time for now. But we remember that if you ask for period, we can find these three things, either omega t or f. If you have any of it, then we are able to just convert to period. Is there any omega? No. Is there any frequency? No. So, well, this is not the case for now. We cannot do this using this way. So what other information is given? We have already used this information. So how about we try to make use of this information here? Okay, So let's slowly unpack this situation. I should write this as k when x is equal to 0, just to be very specific. Okay, so we know that E total energy is equals to k plus U. But you know that when x is equal to 0, the object is at its equilibrium position. If it's at its equilibrium position, what happens is there will be no potential energy, right? Imagine a spring. If it's at its equilibrium state, there will be not stretched, not compressed, so there will be no elastic potential energy. So what we can say here is U is equals to 0. Okay, so since we know that, we can safely say that E when x is equal to 0 is equals to k when x is equals to 0. But we also know that the total energy is always constant, so it's just equal to E. Okay, the next thing that we also know that E is equals to half m omega square A square. Okay, we know this as the formula for total energy. So I believe it's about time for us to link a few things together. We can probably link this up because this has omega, which we might be interested in, and we link this with a known value. We know this value to be 45 joule. So maybe it's a good idea for us to connect these two things together. So let's try to connect it. So 45 is equals to half m omega square A square. I think this is the right way forward because you have mass is given to you. You have the amplitude is given in the graph. So what will come out if you solve everything will be omega, and omega, as you know, can be related to period and frequency. So you get what you want. Okay, so let's proceed with the substitution. Half 3.0 omega square, if it there, amplitude you put in 0.2 square. Okay, so if you proceed to calculate everything, what will come out will be omega will be equals to 5 square root 30, and 5 square root 30 is basically just 27.4 radian per second. Okay, so this is the angular velocity for this object, for this body, and oscillating in simple harmonic motion. So we are not finished yet. The question asks for period, so we have to switch things up. You know this formula, we rearrange it to the form that we want, make a substitution here, and there you have it. Oops, the answer will be 0.23 seconds. Okay, so this will be our period. So we have solved amplitude, we have solved period. Last thing will be to go for the maximum acceleration. Maximum acceleration, the formula we have used it quite a lot of times already, plus minus a omega square. Now it's just a matter of substitution. Again, 0.2 meter. Omega is, let me just write this. Okay, 5 square root 30 square. Okay, and the 5 square root 30 comes from here. Omega here. Okay, so if you calculate everything, the answer that you will get is plus minus 150 meter per second square. Okay, so there you have it. The maximum acceleration is plus minus 150 meter per second square. Plus minus because there's positive and negative direction to consider. Okay, that's it for question number 8. Thank you very much.